The ecoacoustic soundscape is composed of a range of different elements. So we have anthrophony, those are human-generated noises that influence this acoustic soundscape. We have geophony, those are things like wind and water, generally earth-driven sounds. And then we have biophony, which is the sounds that vocalizing fauna make. So the frogs and insects and birds and koalas and other fauna that communicate with sound. We can look at the ratio of anthrophony and biophony, and from that we can understand the impacts that such anthropogenic sources of sound may have on biodiversity, inhibiting communication, inhibiting mate recognition, for example, amongst animals and so on. This overall will give us insight into the ecological condition of the site, the health of the site, if you like. And while we can look around and we can measure certain things like vegetation and certain species, the sound gives us more of a, measuring or examining the soundscape gives us more of a holistic interpretation of those impacts at a community and landscape level. So that's why we're really interested in using this ecoacoustic approach to understand how future developments at this particular site might influence the biodiversity.
One of the things that's probably going to happen down the future is that housing is going to come into this area at some point or another. So what we want to do with this project is look at how we can visualize sound to be able to help urban designers or landscape architects to pinpoint where the best opportunities for development might be on this property down the track, so that we can maintain the biodiversity as much as we possibly can through monitoring it through sound, which I've never seen any landscape architects do to this point. So it'll be very interesting to see the results and how we can actually use the data.
My project is based on a property owned by the Queensland Trust for Nature out at on the way to Peaks Crossing, and we're looking at using vegetation assessments in combination with your spatial mapping and your GIS data and a soundscape, so using acoustic sensors to generate a 3D visualization of the property. So we've got our sensors placed out in different locations across the two sections of the property in order to generate 3 different visualizations of the sound that we're picking up. So we're getting the birds, the insects, maybe even some koala bellows if we're lucky at night time, and putting that all together to generate a soundscape that uses an index as a rating to get the generation of the amount of sound at each particular site. So what we're doing today is we've set out 12 sensors around the property that are geo-referenced, like this one, and they're stuck to a variety of different trees in order to get the overall soundscape of the property.
We use acoustic technology, acoustic recorders, to record or monitor the sounds of the environment, and in that way we can study the ecology of a particular site, such as this one, which has been heavily impacted in terms of clearing and grazing. And what we hope to do with ecoacoustics is basically get a measurement of the health or the ecological integrity of the site. And we do that by understanding the relationship between human sounds or anthropogenic sounds and impacts with biological diversity.